All right, everyone, let's start. And just a reminder, at the end of the talk, there will be a Q&A session. So if you have any questions, please come down here at the front so I can take your questions. Enjoy the talk.
Hello, my name is Milana Vuckovic. Same as James that talked a little bit earlier. I work at ECNWF, and I also shared an office a couple of years ago with Julia, who I think it might be that introduced me to Jupyter Notebooks. So this is interesting. So I will be talking about using Jupyter to make weather forecast data more accessible to users. So a little bit, if you don't remember, and just for you to learn, European Center for Medium Range Weather Forecast, where I work, is an international organization, intergovernmental organization, having 35 member states and cooperating states, running 24 hours operational weather service, and supporting national weather services and businesses over Europe and the world, and also an research institution. We run the two Copernicus services, and also we support Copernicus Emergency Management Service. And together with EUMETSAT and ESA, we also, since a year ago, we run a Destination Earth project, which builds digital twins of the Earth. But we also participate in many European Commission-funded Horizon projects. I work on one of them, and here's some nice logos for you. So what my talk is about. So until just a couple of years ago, all of our data, almost all of our data was closed. It was hidden under many licenses. So in each of our member state country, the country's Met Service was and still is in charge of the data license. In 2019, we made a roadmap to make our data open in the next couple of years, but we can't do it right. We can't just make all the data open. We have to make it gradually. So in 2020, first thing that we did was we opened our static web charts. So all of the static web charts that we produce are open since 2020, and archive data is also open since 2020. And since January 2021, we opened a subset of our forecast. So some most important parameters at reduced resolution are now open. But you can't just open meteorological data, because if anybody of you tried to use meteorological data, they come in very specific meteorological formats. Parameters, some of them are very specific to meteorology. So we needed to make an extra effort to make this data fair. So we designed an API to easily download this data. And we, at the same time, started making libraries that make processing easier and processing and visualization easier. But together with that, we decided to publish a number of Jupyter notebooks that will showcase how to use this data and how to use these libraries as well. So what is weather forecast data? So at ECNWF, we produce medium and extended and long-range weather forecasts. So not for the first few hours, but for 10 to 15 days in advance. This we produce every 6 hours and up to 2 weeks ahead. Then what we call extended range is the data up to 6 weeks in advance, which we produce twice a week. And from next month, we will produce it every day. And the long range, which is the forecast up to 6 months or 1 year in advance, which we produce every month. It is produced for a coming month or a season, not daily data. And one subset of this is now open with the CC by 4 license, and it's available from our service, but also from Amazon Web Services Cloud and Microsoft Azure. And it is governed by the CC by 4 license. So what is in this free data set? It is all our 51 ensemble members. It is at a lower resolution than our operational data. So our operational data is available at 0.1 degrees, but open data is 0.4. It is available at 9 significant levels in meteorology, 4 runs per day, and forecasts for up to 10 to 15 days. And some of the most used parameters available there. So I just want to show you a little bit about these open charts, just for you to know what my notebooks will talk about. So these are available since October 2020. It is a set of static maps, and there are around a bit more than 200 of them. So when we run a model, we have these raw fields in grid files, and then we need to do some computing and processing in order to produce them. We first produce interactive data for interactive our platform, which is not open. It is available only for meteorologists in Met Services. And I will just, OK, it will not work. I will try. OK. Come on. OK. So this is what it looks like. So it is very interactive. All of our products are available in the open charts. And it is also available, the data is also available through WMS service. This is where the data is, the images are produced for the open charts. So the open charts are static, and then the catalog is available, and anybody can use it even if they are not logged in. And so yeah, it is combinations of different parameters. For example, wind and temperature, precipitation and mean sea level pressure, clouds, and whatever combination might be useful. So you can, you can find them on the, if you scan the QR code. And so what happened? We often have users asking us, oh, how do we reproduce these charts? What parameters do we need? How do we calculate this? How do we set the colors? So it is a burden to our user support, and my colleague Emma from user support came with the idea, oh, why don't we have one Jupyter notebook for every product that we have? And I said, OK, challenge accepted. So I set on a mission to make a Jupyter notebook for every product. So a Jupyter notebook that we explained which data is used, where to find more about these parameters, where to download it, how to find it, how to download it, how to calculate if something needs to be calculated, and in the end, how to plot it. So what was the challenge here? Was it making 240 notebooks for 240 products? Well, no, because most of these actually can be automated with Jupyter notebooks. But my actual challenge is there are many products here that their production, they were started producing like 20 years ago, and then it works, and they were never changed. So some of our products are made using Fortran. Even visualization is done in Fortran. So actually, there's now a need to redo these products using the tools that are available now, and then document them and produce notebooks. So how do I do this? I had to first categorize all the products in can they be reproduced using open data, or some of the data that is used there is not open. Then I divide them. Are they very simple, or they need some calculating? Are they those that need updating or don't? And then, in the end, are they scalar, vector, what should we use to visualize them? And then make a template for each case. And then I get, so all the information about producing the products is in a MongoDB database. So what I do, I take the metadata, I pick in which category, which template I will use. I modify a template, tweak it a little, and publish, and then repeat it 200 times. But if this was the case, it would be too easy, because all the products are are produced using our own internally developed software that used to be working in Fortran. Then it had its own API. Now it has a Python API, but we also want it to work with the other Python ecosystem libraries. So around the same time when we opened the data and opened the notebooks, we started working on on new software for processing and visualizing the data that would work better with all the other software out there. So when I started working on the notebooks, we thought it would be a good idea to use them and to promote this software. So back in 2021, when we did this work, it was the libraries called ECNWF Data and Magpie. But now we are changing that as well, and that will bring me to my next challenge, which is maintaining the notebooks. Because these libraries are not only fast changing, but we will actually this year replace the libraries that are used to produce and visualize the data. And also there's 200 of them. And so it has to be automated and it has to be easy. And then this is where I don't know any other tool that I could use besides Jupyter, because the Jupyter notebooks are JSON files, and I can make a script that goes through the notebooks and then just replaces what I need to be replaced. So for example, last year, our user support decided to change all the links to our documentation. So I had to go to all the notebooks and change all the links to the documentation, and it was done. It was very easy because I could it's just a dictionary, and then I just go and change it. And also, since that time, I also realized that I could not only tag the notebooks, but I can tag the individual cells, telling to myself, okay, this is the cell where my thumbnail is, if something is changed, where the links to the product itself, where the links to the data, where the links to the libraries. So then it makes my life super easier for when I need to update the notebook. So for now, it was like a proof of concept, and I made 50 notebooks, but the plan is to make a notebook for each of 240 products. So a little bit on how to find them. So they are for each of the parameters. Each of the products comes with these little links. You can directly open each of the notebooks on the GitHub, on Binder, if it works, and in Google Colab. But also all of them are together in GitHub. They live together in the same repo. So you can, once you see one, you can go and see all the others. And I have a slide here showing you how to do this, but I can just show it to you live and pray it works. So, so this is the charts.ecmwf.int, and each of the products that has a notebook has a little, has this now. And we can open it in GitHub, or we can pray that it works on Binder, but I'm not so sure. So they are here. So they are all structured. So when I started this, I thought I have to structure them really the same ways so that I can update them more easily. But since I discovered the tags, it doesn't matter anymore. So they all have like a little bit description, like a thumbnail of the product, a little bit about our licenses, and then links to each of the parameter that is used, which we have like a parameter database for all of them, so users can actually see and read more about this. More about this parameter, and then there are links to the libraries that are used to calculate and download and visualize, and then it's the code. I'm personally a fan of putting as little code as possible in one cell, and explaining what each cell is doing. So it's easier for somebody who is coming for the first time not to have to read several lines of code and trying to understand it. But so in these notebooks, mainly, each line is explained, and then it's easier for the users. So that is mainly it. So when you open the product, also the notebook for each product can be found a little bit more hidden, but it's there. And then the same dialog shows there. And that's about it. Thanks.